How human eye color changed after leaving Africa. Look into a mirror. What color are your eyes? Brown? Blue? Green? Here's something that might blow your mind. If you could travel back in time 10,000 years and look into the eyes of your ancestors, no matter where you're from, you'd see the same color staring back at you. Brown. Every single time. Every human being who walked the earth had brown eyes. Not a single blue, green, or hazel eye existed anywhere on the planet. And yet today, nearly 80% of Europeans have light-colored eyes. So what happened? How did humanity go from a world of exclusively brown eyes to the rainbow of eye colors we see today? The answer is a story that spans continents, tens of thousands of years, and involves one of the most dramatic transformations in human evolution. This is the story of how human eye color changed after leaving Africa. And trust me, it's way more fascinating than you think. Let's rewind to about 200,000 years ago. Modern humans, Homo sapiens, first appeared in Africa. And every single one of them had brown eyes. But this wasn't random. It was survival. Africa, especially near the equator where early humans lived, is incredibly sunny. The sun's ultraviolet radiation is intense. And here's where eye color comes in. The color of your eyes is determined by melanin, the same pigment that colors your skin and hair. Melanin isn't just about looks though. It's armor. In your iris, the colored part of your eye, melanin acts like natural sunglasses. The more melanin you have, the darker your eyes, and the better protected you are from harmful UV rays. Brown eyes have high levels of melanin. This protection was critical because too much UV exposure can damage the eye and even cause vision problems. So in Africa, under that relentless sun, brown eyes were an evolutionary advantage. They helped our ancestors see clearly, hunt effectively, and survive. For thousands and thousands of years, this was the only eye color that existed. But here's the key: as long as humans stayed in Africa, there was no reason for eye color to change. Brown eyes worked perfectly. Natural selection kept them that way. Every baby born had brown eyes. Every adult who survived had brown eyes. It was universal. Deep in our DNA, we all carried the same genetic instructions for eye color. The genes responsible were set to produce lots of melanin. And without any pressure to change, those genes stayed the same, generation after generation after generation. But then, something happened that would change everything. Around 70,000 to 100,000 years ago, small groups of humans began leaving Africa. They moved into the Middle East, then spread into Europe, Asia, and eventually to every corner of the globe. This wasn't a quick trip. This migration took thousands of years, with groups slowly moving, settling, adapting, and moving again. When humans reached Europe, they encountered something they'd never experienced before: a dramatically different environment. Europe was colder, darker, and had far less sunlight than Africa, especially during the long winters. In northern Europe, the sun sits lower in the sky. Days are shorter in winter, sometimes just a few hours of weak daylight. The UV radiation that had been so intense in Africa was now much, much weaker. And this changed everything. Here's where it gets interesting. Humans need sunlight to produce vitamin D in their skin. Vitamin D is essential for bone health, immune function, and overall survival. But there's a catch: melanin, that protective pigment, blocks UV rays. That's great in Africa where there's plenty of sun, but in Europe's dim environment, too much melanin meant people couldn't produce enough vitamin D. Early migrants to Europe faced a serious problem. Their dark skin, which had protected them in Africa, was now preventing them from getting enough vitamin D, and natural selection kicked in. Over many generations, humans in Europe evolved lighter skin to absorb more of the limited sunlight. But skin wasn't the only thing changing. The genes controlling melanin production were mutating. And some of these mutations affected the eyes. Sometime between 6,000 and 10,000 years ago, a remarkable genetic mutation occurred in a single individual near the Black Sea region. This mutation affected a gene called OCATWO, which regulates melanin production in the iris. This person was born with blue eyes. This wasn't planned. It wasn't intentional. It was a random genetic accident. But here's the amazing part: scientists have discovered that every single blue-eyed person alive today descends from this one individual. You, your blue-eyed friend, blue-eyed celebrities, all trace back to this single ancestor. So what exactly happened in that person's DNA? Let's break down the genetics, and don't worry, I'll keep it simple. Eye color isn't controlled by one gene, it's controlled by multiple genes working together. The two most important ones are OCA2 and HERCT, both located on chromosome 15. The OCA2 gene is responsible for producing melanin. The HERCT2 gene acts like a switch that controls OCA2. In that first blue-eyed person, a mutation occurred in the HERCT2 gene. This mutation acted like turning down a dimmer switch. It didn't turn off melanin production completely, but it reduced it significantly in the iris. The result? Blue eyes. But the story doesn't end there. As humans continued to spread and populations mixed, more mutations occurred. Different combinations of genes led to different amounts of melanin, creating the spectrum of eye colors we see today. Green eyes, the rarest of all, result from a small amount of melanin combined with light scattering in the iris. Hazel eyes are a mix of brown and green, caused by moderate melanin levels with an uneven distribution. Gray eyes are similar to blue but with even less melanin and different collagen structures in the iris. Today, brown eyes are still the most common, found in about 79% of the world's population. Blue eyes appear in roughly 8–10%, hazel in about 5%, green in only 2%, and other colors like gray and amber make up the rest. And here's what's fascinating: eye color distribution follows geography. In Africa, South America, and Asia, brown eyes dominate, often reaching 95% or more of the population. In Europe, especially Northern Europe, light eyes are common. In Finland, for example, about 89% of people have blue or light-colored eyes. You might wonder, if my parents both have brown eyes, why do I have blue eyes? Or vice versa? This happens because eye color is polygenic, meaning multiple genes are involved, and you inherit different combinations from each parent. You can carry genes for light eyes even if yours are dark, and pass those genes to your children. Now here's the big question that scientists have debated: did light-colored eyes spread because they provided some evolutionary advantage, or was it just random chance? Let's look at the theories. Theory 1. Sexual selection. Some scientists believe light-colored eyes spread through sexual selection. In other words, people found them attractive and were more likely to choose partners with blue or green eyes. This isn't as superficial as it sounds. In evolutionary terms, if a trait is consistently chosen by potential mates, it spreads through the population, even if it doesn't help with survival. In the Northern European environment where blue eyes first appeared, they may have been seen as exotic, unusual, or beautiful. This could have given blue-eyed individuals a mating advantage. Over thousands of years, this preference could explain why light eyes became so common in Europe. Theory 2. Genetic drift. The second theory is genetic drift. This is when random chance, not natural selection, causes a gene to spread. In small, isolated populations like early European groups, random mutations can become common just by luck. Imagine a small village of 100 people. If one person has a mutation for blue eyes and happens to have many children who survive, that gene can quickly spread, not because it's beneficial, but simply because of random reproductive success. Theory 3. Linked traits. A third possibility is that the genes for light eyes were linked to other genes that did provide survival advantages. For example, the same genes that reduced melanin in eyes also affected skin color. Lighter skin was definitely advantageous in low sunlight environments for vitamin D production. So blue eyes might have spread not because the eyes themselves were beneficial, but because they came packaged with lighter skin that was beneficial. Most scientists today think it's probably a combination of all three factors. Light skin was selected for because of vitamin D, but once the genes for reduced melanin existed, sexual selection and random drift helped spread eye color variations. Here's something to ponder. Do light-colored eyes actually have any functional advantages or disadvantages today? Some studies suggest people with light eyes may be slightly more sensitive to bright light and have a marginally higher risk of certain eye conditions. But in modern society, with sunglasses and indoor lighting, these differences are minimal. The point is, evolution doesn't always work toward perfect optimization. Sometimes traits spread simply because they don't cause harm, or because we find them appealing. So what does this incredible journey of eye color tell us about ourselves? First, it reminds us that we're all connected. Whether your eyes are brown, blue, green, or hazel, we all share ancestors who lived in Africa with brown eyes. The diversity we see today is recent in evolutionary terms, just a few thousand years old. We're all part of the same human family. Second, it shows us how adaptable humans are. When our ancestors moved from Africa to Europe, their bodies changed to fit new environments. Lighter skin, lighter eyes, different hair textures. This is evolution in action. We're not static creatures, we're constantly shaped by where we live. Third, it demonstrates how random mutations can reshape a species. That one person with a mutation for blue eyes near the Black Sea had no idea their genetic quirk would spread to millions of people. Evolution works through these random changes, and natural selection or chance determines which ones spread. Fourth, it challenges our ideas about race and difference. Eye color, like skin color, is superficial. It's controlled by a handful of genes out of the 20,000–25,000 genes humans possess. We've built entire systems of categorization around these tiny genetic differences, but from a biological perspective, we're remarkably similar. Finally, it makes us wonder about the future. Today, humans live in every environment on Earth, from the equator to the Arctic. We have technology that protects us from environmental pressures. We have vitamin D supplements, sunscreen, and sunglasses. Will human eye color continue to evolve, or has modern technology stopped natural selection in its tracks? And as populations mix more than ever before through global migration, what will happen to eye color distribution? Will certain colors become more or less common? Will new combinations emerge? We don't know for sure. But one thing is certain, the story of human eye color isn't finished. It's still being written with every generation. The next time you look into someone's eyes, remember, you're looking at a story that spans continents and tens of thousands of years. You're seeing the result of migrations, mutations, adaptations, and chance encounters that stretch back to our earliest ancestors in Africa. Those eyes, whatever color they are, connect us to the past and to each other. If you found this story as fascinating as I did, hit that like button and subscribe to the channel. We explore the hidden stories behind everyday things you've probably never thought about. What should we investigate next? Drop your suggestions in the comments below. And if you want to keep exploring human evolution, check out our video on how skin color evolved, or our deep dive into why humans lost their body hair. There's a whole universe of incredible science to discover. Thanks for watching, and I'll see you in the next one.